Welcome to the session on constant acceleration, displacement time graphs. The objectives for this session are to understand and interpret displacement time graphs. Constant acceleration. When a body falls freely under gravity, it can be assumed that it has constant acceleration. Let's now take a look at a few graphs and see what's happening in them. This graph shows the time in seconds on the x-axis and the displacement in meters from a given point on the y-axis. This graph indicates that there is no change in displacement over time, and it implies that the body is stationary. The second graph again has time on the x-axis in seconds and displacement in meters from a given point on the y-axis. The displacement is increasing at a constant rate over time. This graph implies that the object is moving with constant velocity. And now for this graph. Again, the time in seconds is on the x-axis, and the displacement in meters from a given point is on the y-axis. In this graph, displacement is increasing at a greater rate over time, and the graph implies that the velocity is increasing and therefore the object is accelerating. So let's summarize the key points again. This graph indicates that there is no change in displacement over time and implies that the body is stationary. This graph indicates that displacement is increasing at a constant rate over time and implies that the object is moving with constant velocity. And this graph indicates that the displacement is increasing at a greater rate over time, which implies that the velocity is increasing and therefore the object is accelerating. Velocity is the rate of change of displacement. The gradient on a displacement time graph represents velocity. The formula for the average velocity is displacement from the starting point divided by the time taken. And the formula for the average speed is the total distance travelled all over time taken. So let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 1 part A first. A girl drives to a shop 4 kilometers away for 25 minutes on a straight road. She stays at the shop for 15 minutes and then returns back on the same road in 20 minutes. Calculate the average velocity for each part of the journey in kilometers per hour. So here are the key points in the example which have been highlighted in red. Let's now solve this. Let's first begin by sketching a graph to help us see what's going on. We have time on the x-axis and distance or displacement on the y-axis. In the first part of her journey, she drives to a shop 4 kilometers away in 25 minutes. And so here's the first part of her journey indicated by a straight line on the graph. Now for the second part of her journey, She stays at the shop, so she travels 0 kilometers for 15 minutes. So here's the second part of her journey, indicated by a straight line on the graph. And now for the final part of her journey. She then returns back on the same road, so of course she's travelling 4 kilometers altogether, and she goes back in 20 minutes. So the last part of her journey is as indicated by the line on the graph. And here's her complete journey. We are required to calculate the average velocity for each part of the journey in kilometers per hour. So from O to A, we have that the velocity is equal to 4, which is the displacement in the positive direction, divided by the length of time, or the time taken, which is 25 minutes. The second part of the journey, from A to B, or the vector AB, is 0 divided by 15. And the final part of the journey, because she's going back, so in the reverse direction to the positive direction, and we're looking at displacement from the starting point, she's therefore travelling minus 4 kilometers in 20 minutes. So minus 4 over 20. And of course, all of these units are in kilometers per minute. However, we are required to find in kilometers per hour. So let's see how we can convert from one unit to the other. How do we convert from per minute to per hour? 60 minutes, of course, equals 1 hour. Therefore, if we divide by h and min on both sides, we have 60h to the power minus 1 equals 1 minute to the power minus 1. So now we can convert the velocities. Since we have 60h to the minus 1 equals 1 min to the minus 1, we can now substitute as shown. So min inverse is replaced by 60 times h inverse as shown. And this gives us the values as shown. And tidying up gives us velocity OA is 9.6 kilometers per hour. Velocity AB is 0 kilometers per hour. And velocity BC is minus 12 kilometers per hour. And now for part B. We are required to work out the average velocity for the entire journey. So let's solve this. The displacement for the entire journey is 0. The girl travels 4 kilometers, so plus 4, and then returns on the same road, so minus 4. We're looking at displacement and not distance, so direction is important. And this is why displacement is 4 plus minus 4, which is 0. Therefore, the average velocity is 0, since velocity is displacement over time. And finally, for part C, we are required to find the average speed for the entire journey. So let's solve this. We've highlighted the key points in red in part C. So the girl is driving to a shop 4 kilometers away and then returns back on the same road. And we're finding the average speed for the entire journey. So the total distance is 4 kilometers plus 4 kilometers. Since we're looking at speed, the direction in which the girl is traveling is not important anymore. So the total distance is 8 kilometers. The total time now has been highlighted. So 25, 15 and 20 minutes for each part of the journey. We add the three together and that gives us 60 minutes altogether. Of course, 60 minutes is 1 hour. Therefore, the total time is 1 hour. And the average speed is 8/1 kilometers per hour, which is of course 8 kilometers per hour. This brings us to the end of this session. If you have understood its contents, you should be able to understand and interpret displacement time graphs. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.